Question 15, which is also a Cambridge question. The top of the cliff is 40 meters above the level of the sea. A man in a boat close to the bottom of the cliff is in difficulty, fires a distress signal vertically upwards from sea level. Find the speed of projection of the signal given it reaches a height of 5 meters above the cliff, the length of time for which the signal is above the level of the top of the cliff, and then it gets more complicated. The man fires another signal vertically upwards from sea level. This signal is above the top of the cliff for 17 seconds, root 17 seconds. Find the speed of projection of the second signal. Given that part 1 says it reaches a height 5 meters above the top of the cliff, we're going to assume that that is as high as it gets. It doesn't get any higher. So that's where its instantaneous velocity is 0, and it would, if it kept going, would start coming back down to the ground. So we can use this information to work out the initial velocity. What do we know? We know that the displacement is going to be 45 meters, the cliff plus another 5 meters. We know that the acceleration is negative 10 meters per second squared. We know that the final velocity, because it's the top, is equal to 0, and we want to find out the initial velocity. So what formula uses SA, V, and U? Be the last one. V squared is U squared plus 2AS. All right, so we put in what we know. Well, V is 0. So let's take the U squared, well, let's leave the U squared where it is. Take the 2AS over to the other side, and we'll get 2 times negative 10 times, we took it over, the negative becomes a positive. 2 times 10 times 45. All right. Did a few things there that tricked myself. Since V squared is 0 and we had the U squared sitting there, took the 2AS over to the other side. And because we have the minus 10 with the A, when we took it over, it became positive, which is very helpful. Of course, we have to do the square root. So we have U squared is the square root of 900. U is the square root of 900. And then, of course, that makes the initial velocity equal to 30 meters per second. All right, part 1, done. For part 2, we're trying to find the length of time where it is above the top of the cliff. And so what's actually happening here is at the top of the cliff, it's going to go up and then come back down. And so we want the length of time between those 2 points where it goes up and comes back down. Right, well, this actually is not that complicated. We know that's 40 meters above where it started. And so now that we know the initial velocity, we can say, given that the initial velocity is 30 and acceleration is negative 10 meters per second squared, of course, we know that the displacement is going to be 40 if we're trying, and we're trying to find time. Okay, so the way that it's set up there, it's going to give us 2 answers for the time because it is at the position of 40 meters above the boat twice. So which formula do we use? Use the one that relates all of those together. S equals UT plus a half AT squared. Put in what we know, and we know that 40 is equal to 30T. Half A is minus 5T squared. All right, let's simplify it and take everything over to the other side as well. So divide everything by 5. We take the 5T over, it will just become T squared. We have 30T divided by 5, we get 6. So it's going to be minus because we're subtracting it now. And divide 40 by 5 and we get 8. And now it equals 0. All right, can we factorize that by inspection? Multiplies to 8, adds to negative 6. Yeah, 2 and 4, right? So we get T minus 2 or T minus 4 equals 0, which tells me that time is 2 seconds or time equals 4. But these are the times where it is at the point at the height of the cliff, which is 40 meters. And so we know time above is 4 seconds when it's on its way back, minus the 2 seconds when it was on its way up, which of course the answer is 2 seconds. Part 3 has got just a little bit more complicated. It's now saying it's root 17 seconds above the top of the cliff, which is 4 point something. And we just worked out it was 2 seconds above so obviously it has to be 5 faster than the 30 meters per second that we had before. At least that gives us something that we're aiming for. We can check with our answer. All right, so I'm going to do a little analysis based on the instantaneous velocity being 0 again. So this is the top of the cliff, and what we know is it goes up and then it reaches a peak and it comes back down, and at the top the velocity is 0. Okay, because it's symmetrical, it's a parabola, the value, then the time on one side of the parabola is equal to the time on the other side. So this amount of time is going to be half of the root 17 on 2, and this amount of time is also going to be half the root 17 on 2. So it's going to be extremely beneficial for us to work out, well, what's the height above the cliff that it actually reaches? And we can do that by saying, that's what we want to find, the displacement. The time for this displacement is going to be root 17 on 2. Half of the time above the cliff it's going to be falling, and half of the time it's going to be going upwards. So we're going to start, and why do we do half? Well, because then we can start an initial velocity of 0. We can say it's at the instantaneous rest. And we also know the acceleration is -10, and we want to find the displacement, of course. Okay, so we know 3 things, and we'll be able to work out the displacement. What relates all of these together? S is ut plus a half a t squared. Right, u0, so it's looking nice already. So the displacement is equal to a half of the acceleration, which is -5. T squared is root 17 on 2 squared. Root 17 on 2 just turns into 17. Which is nice, and then we divide by 4 and multiply by 5, and that gives us -21.25. Right, so remember that's the displacement from where we started, and we started at the top. So the actual height above the cliff that it reaches is 21.25 meters. So what we actually know now is a lot. We want to find the initial velocity that you got released from the boat. That's our question mark. We're going to go to the top of it, the highest that it reaches. So that's where the velocity is 0. From the boat to where it has instantaneous rest. We know the distance, and the distance or the displacement is going to be the 40 meters of the cliff plus the 21.25 meters above the cliff, which makes 61.25, and acceleration is still the same, -10 meters per second squared. All right, so we've got UVSA. Which formula do we need for that? V squared is U squared plus 2AS. So U squared is V squared minus 2AS. V is 0, so we don't have any of that. So we're going to subtract from 0. All right, we'll write it. 0 minus 2 times acceleration, which is -10, times S, which is 61.25. What does that give us? Well, the negative and negative is very nice. That makes U equal to the square root of 1225, which tells me the initial velocity is equal to square root of that, which is 35 meters per second.